In 1979, Harman Kardon's top-of-the-line receiver was the HK670. The model right below that, the HK560, this guy right here, sold for $399 or about $1,750 today. And it was listed as having 40 watts per channel into 8 ohm loads at not more than 0.04% THD. There were not a lot of other specifications other than that. Now, we will go into how it performed on the bench and the listening test that I did on it and using it and that kind of thing a little bit. I'll do the standard tour. You know, we'll look up front, look up back, pop the cover, and look inside. Now, I should brace you. For the inside isn't so pretty in one of the output transistor areas, and I'll explain that a little bit more shortly. Now, this guy came to me via way of a trade with one of my friends. I traded him a piece of gear, and he traded me this with the caveat that he thought it needed some work. He hadn't tried it in years, but he thought it needed some help. So I said, no problem. I'm sure it's just scratchy pots and dirty switches, that kind of thing. When I got it home and hooked it up to the QA403 analyzer and some loads, I discovered the distortion was pretty bad for both channels, and so was the frequency response. And you're going to see plots of what it looked like before and after the repair on this unit. It looks like it had been repaired at some point during its lifespan. The output transistors were the original ones, at least as far as part numbers. Maybe they were replaced at some point in time. You could tell from looking at the board that there had been some soldering and unsoldering going on throughout the board, so I'm not really sure, you know, what happened, and my friend didn't remember any history on it. So anyway, it did take me a while to go through and figure it out. During the process of troubleshooting it, I should not troubleshoot things late at night. My little probe slipped and shorted out one of the collectors to someplace it shouldn't have. I saw a little spark, a fuse blew on the unit, and of course it took out 2 output transistors on the left channel. The emitter resistors were still intact, that was good, but there were some other parts I found bad. The really bad thing is that the output transistors are no longer available. Luckily, I was able to get an ECG, a new old stock ECG part for the PNP transistors. The NPNs I had to pay 3 times the price and get them online, and that transistor turned out to be a bigger package. It's an odd package, and you'll see the picture of it. So it was a bigger package, but I was able to get it to work, and it's not very pretty as far as things go, but it's working really well, and it's my own unit, so it doesn't have to go anywhere. And then I had to do some adjustments to get the bias currents down quite a bit on this guy. So I'll show the schematic and kind of what I found and what I did. And it's not real pretty, like I said, but it's working really good. It has a happy ending, at least so far. So we'll get into the tour and all that shortly. I did do a quick search for these on the internet, and I didn't see any for sale. All they sold were lamp replacement kits for these, and luckily all that was good for this unit. All the lights work really well. So as you can tell, they're on, and I'm very happy with the looks of this unit. So let's get into the tour. So let's start the tour of the HK560. Let me go ahead and turn it on right here. It has an LED to let you know that it's on in case your lamps are burned out, which they are not. I do like the light orange glow that they have to the backplate and all that. It looks really nice in my opinion. You have your 1/4-inch headphone jack, bass and treble controls, and a balance control, and those are all center detented. You will see that the balance control is pointing a bit more to the left channel. That was the position I found to give me an equal channel balance. We have our tape monitor switches and tape copy switches there. Our function switch here, it does have a position for FM and stereo FM, as well as auxiliary phono and AM. We have our loudness switch right there, or push button. and our volume control is right there. Of course, our tuning knob is there. If the tape monitor is on, the LED comes on. And the interesting thing about these switches, now I'll list them. Here's our FM muting, here's our mono switch, we have a subsonic filter, we have our tone defeat switch, which is nice in a unit like this, so you can bypass the bass and treble controls if you wanted. And then we have speaker 2 and speaker 1 switches. Now, the way that these guys work is there's actually a mechanical shutter in that mechanism, so when you push it in, it closes the shutter, which allows this backsplade light to not enter the switches. So there's not a separate lamp in there that turns on and off. It actually is taking the lamp for the backlight and cutting that on and off with a shutter type of mechanical switch. So I thought that is kind of cool. And then of course we have our stereo LED that comes on, and we do have our AM and FM signal strength meter. And I should mention that I did test both the AM and FM tuners, and they worked pretty good. With the small antenna that I had for FM, I thought it tuned okay. It's not the best tuner that I've used, but I don't really use a tuner much these days. And I thought the AM tuner worked a little bit better, but overall the tuners do work. Coming around back of the HK560, we have our Phono ground lug there. Our inputs for Phono and auxiliary are here. Our tape monitor inputs and outputs are here for the 2 tape monitor loops. We have our speaker connection points right here, and on these you press them in and push in the wire from the top for your going to your speaker. We do have something a little unusual in that we have speaker protector resettable fuses for each channel there. We have a switchable AC outlet, and then we have connections for the FM antenna and an external AM antenna, although we do have an AM antenna rod there. One thing I should point out is that if you were running 2 sets of speakers back here, I would really want them to be 8 ohm speakers just to be on the safe side. This thing seemed to work decently with 4 ohm speakers, but if you had 2 8 ohms, it's equivalent of having a single 4 ohm speaker. So I probably wouldn't want to run more than 2 sets of 8 ohm speakers if I were using all 4 of those. Here is a view of the HK560 once the cover is removed, and I kind of wanted to show this view because this is at the point where nothing had been replaced by me. I had removed the screws in the insulating hardware from these 2 transistors, and those are the ones that were shorted. And I kind of just wanted you to see what things look like. I'm a little suspicious about these being replaced. It seems like there's a lot of grease around them, and it looked like there had been some soldering underneath, but they were the original part numbers, so maybe they were replaced at some point in time. And it kind of just shows how things are laid out. The other transistors that I mentioned, the Darlington transistors, are this one and this one here, and you can see that they're not mounted against the heatsink. I saw a video on an HK560 on YouTube where the guy did a pretty good job of explaining about how to remove the dial cord, that kind of thing, and his transistors had lost a lot of gain and he went over replacing them. However, his were mounted to the heatsink here to adjust the bias depending on temperature, I guess, and these did not have any way to mount these, and I did sort of mount them to the heatsink, or sort of got some of the heatsink heat to transfer to the transistors with some thermal compound, and you'll see that in a little bit. But this kind of just shows how things are laid out. This is a view after I replaced the transistors on this side right here on the left channel, and right off the bat you can see that this package is quite a bit bigger than this package. I was only able to use one of the screw holes, this one right here. The other one I didn't want to drill through things, and it just would have been a lot more work. And when I tightened this down, I didn't tighten it to where it was going to be greatly pressed down. I kind of just gave it a firm tightening. And I applied grease, of course, to both sides of the heatsink and the transistor, as well as the thermal insulator for both these transistors. I also mounted those Darlingtons that I mentioned, those Darlington transistors. I didn't really mount them. I just bent them over so that they were almost touching this heatsink here, and then I have the silicone grease around it. Now you sort of can tell that there's some shrink tubing around these two leads. The MPSA 13s don't have the same lead configuration, so I had to swap position of two of the leads and use some shrink tubing so nothing would short out, and that's kind of what's going on there. The other things that were replaced were the resistor right here, and then there's another one here, and for some reason those were open. And then I added another resistor underneath, and I think you'll see that here in a minute. This view is a little out of focus, except right here. I just wanted you to see that there is no screw in this part of the heatsink, and you can kind of see a little bit better that those transistors are bent over and just touching the heatsink with grease under them. And I believe the other two diodes I replaced were these two guys right here. So this is the underside of the HK560. The transistors I replaced were right here, and then there's the Darlington. And what I ended up doing was cutting a trace right here, and then I put in a 20K resistor here and here, and it's basically in series with that 2K pot in order to get the bias currents down to a reasonable level for this guy. Here is a partial schematic for the HK560. What's really nice is this could be downloaded from like Hi-Fi Engine, and the quality is really good. It gives a lot of information, including voltages at the transistors, and it also has a very nice components layout so you can see where things are located on the circuit board. Now, as I mentioned, I had inadvertently shorted out either this point or this point to some other place where it shouldn't be. So these two blew, one of the fuses here blew, and I blew these two diodes. Now the two diodes I was able to cross to an ECG 116. I went with a higher rated diode. I forgot which one I used, but these guys I had in stock. These two transistors are no longer available. Luckily, the local electronics parts store here in town, Elliott Electronics, they have a lot of NTE ECG parts still. They had this guy right here, which is the ECG 381 or NTE 381, and they were like $5.50 each. So I bought two of them. This guy right here is an ECG 380. They did not have that. I ordered the 2S D588 from Dalbani, I believe it was. I've had good luck with them. They're here in the States. But this guy costs, I'll say, about $18. Now, it turns out that this guy that I got, the one from Dalbani, is a bit bigger package than the original one. So the originally came in a package called the TB33. This guy was like the large version of the TB33. I was able to get it to work, as you saw in the tour version, and so it did work. And what I did is I measured the beta of this guy, and I took the one that was closest between the two transistors I bought for this guy, and so I used those, and I got it all to work. I used a lot of grease. So the other thing I had checked right away were the emitter resistors. Those were fine. And whenever output transistors are blown, you always got to check all the parts around it, the resistors and transistors. And the transistors, the best way to test them is to remove them from the circuit. And I have a neat little tool. It's a Peak Atlas DCA 75 Pro. It tests semiconductors really nicely. And so I was checking these two guys. They were good. Then I checked this guy here, which is a 2SC1472K, and it tested good, but its beta was around 200, something like that. And when I was researching repairs that had been done for this amplifier, this particular transistor went real low on one of the videos that I watched, and the guy replaced it with another Darlington. Now, this diagram does not show it as being a Darlington transistor, but when you pull this up, it is indeed a Darlington transistor. The gain is 2,000 to 3,000 for these guys, and this guy was, like I said, reading around 200. So I did some research and found I could use an MPSA 13 transistor, which I did have. It's like an ECG 46. However, the pins are reversed, so you kind of have to use some shrink tubing around the leads and mount it differently than you would the original one. Now, I decided to check the right channel as well for this guy, and it had the same transistor in there. It wasn't a 2SC1472K. It was still good, but it was something with a gain of around 200 instead of 2,000-3,000, something like that. So the other thing that I noticed when I was checking was that there was a resistor that was open as well, and that was this guy right here, this R432. He was opened up, and it was also opened up on the right channel. So I ended up replacing these two on both channels and these two resistors, and then slowly brought things up, and I was able to get the offset voltage adjusted, and that's done with this pot here. For each channel, I got it, pretty close to 0 millivolts, and the bias is set with this resistor here, and you measure it going across this point here and this point here, and it's supposed to be 33 millivolts, and I was up in 200, 300, 400. It just kept going for the bias current through here. So I couldn't really set it. And what I decided to do was to remove this pot here and put in like a 10K pot I started with. And I just started adjusting pots till I could get that bias current down. And I found out after a couple different pots that a 20K pot worked okay. So what I did is I just put in a 20K resistor. I actually cut open the connection between this point and this point and just cut the trace where they both were connected. So kind of right around here. And then I connected a 20K ohm quarter watt resistor in series with this, so I still had some adjustment. I did that on both channels, and I was able to get the bias current down to like 74 milliamps, which was probably double what they said, but it seemed to work well, and it didn't seem to get hot, and that's the way that it stands now. So that's kind of my story on this particular repair. Here is the THD SNR plot at 1 kilohertz that I started with when I first got the unit. When I checked it out, this is what it looked like. 28% THD. It just looks ugly as heck. Surprisingly, SNRs are 78, 79 dB, and this was with it putting out 5 watts into 8 ohms. So I saw this and said, uh-oh, it's going to need some work. Now, after the work, this is what I've ended up with. 0.006 or 0.008% THD, with it putting out about 5 watts into 8 ohm loads. Our SNRs are about the same, but the THD plus noise is much, much better. And this is with the volume control and balance control set so that I got both channels balanced pretty well at 1 kilohertz anyway, and we have about 25 dB of gain. Right now, the HK560 is putting out about 35 watts into 8 ohm loads, and this is at 1 kilohertz. The specification is that it should be able to do 40 watts into 8 ohm loads at not more than 0.04%. Well, we're pretty darn close to 0.04%, and I don't think we're going to make it to 40 watts, so let's see what happens when I increase my signal level just a little bit. So we're at 36 watts. We're still doing good. Increase the input signal a little bit more. You can see it's starting to Get a bit noisier, but we're still better than the 0.04%. We're at 37 watts. Go up a little bit more, you can see that our THD plus noise is getting worse. We're right at the 0.04%, and we're about 37.6 watts, so pretty close. And now we're at 38.5 watts or so, and we're 0.07%, let's say the worst case. Our SNRs are dropping. And if we go up 39.3 watts, we're at 0.1% really on the right channel, left channel 0.07%. So we're not too far away. And we'll go up one more notch, and right now 40.2 watts. The right channel is not as good. It's 0.13% versus 0.09% THD. THD plus noise is kind of ugly. So it's kind of hovering around the spec. Actually, it fails it at THD wise, and there was no spec for the SNR for this. So that's kind of about what we're going to get out of this, with it putting out 40.2 watts into 8 ohm loads. Here are the harmonics with the HK560 putting out 36 watts into 8 ohm loads. You can see the odd or third harmonics are higher than the even or second harmonics. Right now the HK560 is putting a tad over 50 watts into 4 ohm loads. There is no specification for how much power it should put out into 4 ohm loads, but I'm thinking 50 watts it would be a good call. We're at 0.2% THD for the left channel and 0.1% THD for the right channel. SNRs are above 60 dB, and overall it's still working okay at this point. You could probably get a little bit more power out of it, but I'll say that 50 watts into 4 ohm loads would be pretty good for this guy. And here are the harmonics with the HK560 putting out 50 watts into 4 ohm loads. Basically not that much different from when it was putting out 35 watts into 8 ohm loads. The odd or third harmonics are higher than the even or second harmonics. This really ugly frequency response plot for the HK560 from 20 Hz to 20 kHz, with it putting out about 5 watts into 8 ohm loads, was what I started with when I first got the unit. And after many tedious hours of repair, this is the frequency response now. Much, much better. We're down at worst case 0.2 of a dB at 20 kilohertz, and the channels are looking both really good. It's pretty darn flat, pretty impressive. With the HK560 putting out about 5 watts into 4 ohm loads, the frequency response from 20 Hz to 20 kilohertz is pretty close to what it was when connected to 8 ohm loads. It's down maybe 0.1 of a dB more at 20 kilohertz and has a little bit of rise here, very, very small amount. But for the most part, I would say they're pretty much the same. This plot shows the HK560's THD versus frequency for several different output power levels, and that would be into 8 ohms with the volume controls set for 25 dB of gain, and the tone controls are bypassed. We have power levels from 35 watts down to 1 watt, and the specification is that it should be better than 0.04%, which would be right at here. So for the most part, we're meeting that requirement. Here is a plot of the HK560's damping factor from, you guess it, 20 Hz to 20 kilohertz. There is no specification for it. The worst case would be about 28 or so, and then it runs between around 40 to maybe 44. Here is the HK560's crosstalk with the active channel putting out 5 watts into 8 ohm loads. There's no specification for it, but it's actually doing fairly decent with better than 46, 47 dB of crosstalk. Here we have the HK560's multitone response. There is no specification for it, but it's showing a distortion-free range of between 12 to 13 bits. Here we have the IMD response with 19 and 20 kilohertz tones applied. There is a specification that it should be better than 0.06%, and for the left channel we're at 0.03%, and for the right channel we're at 0.01%. So the IMD requirement is being met. Right now we're looking at the system noise level of the HK560. I've got the auxiliary inputs selected, and those inputs are terminated to shorts. We're hooked up to 8 ohm loads. The tone bypass is on, and we have the volume control set for about 25 dB of gain. There is no specification for it, but you can see we're at about, worst case, maybe minus 72, 73 dB or so. So most likely this will have a small amount of hiss when connected to my test speakers. Right now we're looking at the frequency response from 20 hertz to 20 kilohertz with the tone defeat switched on. What I'm going to do is switch the tone controls on. Now both of the tone controls are in their center detented position, so if it were perfect, this trace would stay the same. But let's see what happens when I put the tone controls in, which are once again in their center detented positions. There we go. So now we have the tone controls in. They shouldn't have any effect, but they do. And basically it's showing plus or minus half a dB of effect, more around the lower part of the band than the higher part of the band. But overall, it's really not too bad to have plus or minus half a dB of an effect from just the tone controls in there. Like I said, you would like that to be a straight line down the center, but it is not. Right now we're looking at a plot of the HK560's 2 filter responses. The thick blue line going down the center is with everything set flat. And if I turn on the loudness control, the loudness switch, we're showing about a 9 dB boost here at 20 hertz, and then at 20 kilohertz we're looking at pretty close to 5 dB. If I turn on the subsonic filter, this guy in red, we're showing about a 3.5 dB cut at 20 hertz. Here is the Phono's THD SNR plot at 1 kilohertz with a 5 millivolt signal being applied. There is no specification for it, but overall I would say it looks pretty good. Right around 36 dB of gain. SNR's 53 dB, and the THD is better than 0.002%. Here is the frequency response of the Phono stage with a 5 millivolt signal applied. We're looking from 20 hertz to 20 kilohertz. There was no specification for the Phono frequency response, but at worst case we're up, about 7/10 of a dB and down maybe 2/10 of a dB. So all in all, I would say that this is not that bad. And of course the RIAA weighting is applied. Right now we're looking at a thermal image of the HK560. It has been on for about 40 minutes, and the average power level is probably a little bit over 1 watt, which was fairly loud for the listening situation that I was in. The front of the unit is right here, and you can just make out that tuning knob there. It's obviously pretty cool. What I thought I would do is start showing the heat of the units after I had tested them, just kind of for information's sake, rather than me just saying, oh, it's running real cool or real warm. At least we can have a thermal image now. Now the case is on the unit. The heat sink, above the heat sink, it does have vents, and that's kind of what we're looking at. We have our right channel here and our left channel here. And in the center, which is this kind of white crosshair, it's reading 133.5 F, and the high spot right here with the red crosshair is 158.3 degrees F. So it kind of just gives a little bit better idea as to what kind of temperature this guy is actually running at. Right now we're looking at the rise time of the HK560 with a 1 kilohertz square wave going into the auxiliary input. I've adjusted the level of the signal so that we're getting out probably a tad over 5 watts into 8 ohm loads. Now both channels are being driven. There is no specification for the rise time, but it's really pretty darn good at 1.48 microseconds, and that's for the yellow trace here. Now this was for the right channel, and the left channel is the one that I replaced the output transistor, so I thought I would look at its rise time as well. and it's 1.63 microseconds, so really not a lot of difference, and that's usually pretty good. Usually I'm up in the 3 to 4 microsecond range for the rise time for the things that I have tested so far. This right here is the difference in phase between a signal going into the auxiliary input and coming out at the load, and this would be for the left channel. I only did the left channel for the phase test, at least for the delta phase test, and at 1 kilohertz there's really no difference in phase. If you move the frequency down to 100 hertz, there's maybe 1 or 2 degrees of phase change, and at 10 kilohertz it's probably about 3 to 4 degrees of phase change between the signal going in and coming out. And here is the difference in phase between the left and right channels, with both having been fed a 10 kilohertz sine wave. And you can see there's no difference in phase between the left and right channels at 10 kilohertz. I should mention that the HK560 weighs in a whopping 25 pounds. Another thing I wanted to mention is that they don't list it as a twin power design for the power supply. Some of their units in this time period had that designation as being twin powered. Now, this guy has 2 separate power supplies, one for each channel. They have separate rectifiers and plus or minus B capacitors for each channel. However, they use a single transformer to provide those with the voltages they need. In a true dual mono design, at least the way I look at it, you would have either 2 separate windings for each channel, or you would have 2 separate transformers, one for each channel, if you were a true dual mono power supply design. But this guy did pretty well. Now, there was one specification that it listed, which was it had a dynamic headroom of 2 dB. Now that's in relation to its 40 watts per channel rating, and as you saw from the test data, you really couldn't get it to 40 watts with it looking pretty good. So I used 35 watts per channel into 8 ohms for my calculation of the dynamic headroom, and came up with 2.4 dB, which is pretty good. Now this guy could put out more than 40 watts into 8 ohms, no problem. But if I were rating it, which I guess I am now, I would say it's 35 watts per channel, at least this particular HK560. Now overall, I thought it measured rather well for the specifications that it had. The phono stage measured really well, I thought, and overall it looked really good on the bench, for something that was, the price back in the day. And today it still looks pretty good. It doesn't look like any of the power supply capacitors were replaced on it. My guess is that the output transistors may have blown at some point and they were replaced. They used the same ones, but I can't say that for a fact. It's just when those 2 resistors were opened up and the Darlington transistors were replaced incorrectly, it told me that maybe that something had happened around that area. But anyway, overall, I thought it measured really well. As far as how it runs, when it was hooked up to the Wilson Watt 3 Puppy 2 loudspeakers, and I terminate the auxiliary inputs into shorts, and then I listened for hum and hiss with the volume set for about 25 dB of gain. It had just a real small amount of that 60, 120 hertz hum that you saw in the noise plot, and it's real low. Once you're away a foot, you don't really hear it, so it's not really a factor. And as far as listening to it, I really liked the loudness control being pressed in, and it was throughout all my listening, and it did a really good job. I was playing typically at 1 watt, and it was real nice. I did have my APM 100 power meters, the realistic ones that I did a video on way back years ago, and those were showing me between 1 and 10 watts every now and then, and it got up to probably halfway between 10, whatever the next marking is on that, for a little bit. But I thought it had good bass, good highs, good mid-range. It just sounded really good, and I think it looks good. It has all the basic functions. If you don't need a pre-out main in and you only need 1 auxiliary, this is a nice looking preamp, and if you can, find one that's working, or you know how to fix it, it would be a good choice. Now, as far as some of the repairs, if you had to, get in where you got to remove the front cover, and there's a video on YouTube where the guy goes into quite detail about, pulling off the dial string and all that. I'm not, I'm trying to go through my life without having to remove a dial string thing, and so far I've done a pretty good job of that. But there's a guy that goes into a pretty good video on doing some repairs on his. It's not a fun job if you have to get to the front where you got to start pulling controls and switches apart and to get at them and all that. You're able to get out most of them with some things that I have for getting lubricant sprayed in there, that kind of stuff. So I didn't have to remove the cover off, and I try to make my life simpler when I can, except shorting things out didn't make my life simpler, but it was an educational experience. So anyway, that's kind of my take on this guy. Once again, I think it's a nice looking receiver. If you had an office, or you just kind of want a nice vintage thing that just looks good and sounds good, easy to use, and you can find a Harman Kardon like this, I think you will be quite happy with it. So I would recommend it. Once again, if you like the video, thumbs up. I always enjoy, or I should say I almost always enjoy seeing your comments and reading them, and I do try to respond to all of them as best I can. And if you have not subscribed to the channel, I hope you will consider doing that to allow the channel to grow. And once again, as always, until next time, I hope you have a great day or night.